In Module 9, we're working with different types of quadrilaterals. We've already learned previously that a quadrilateral is a polygon that has four sides. So that's what makes a quadrilateral is that it's a polygon and it has exactly four sides. But now there's specific types of quadrilaterals, one of which is a parallelogram. The most basic definition of a parallelogram, what makes a parallelogram is that it has two sets of parallel sides. The red arrows that you see on the diagram, that's what denotes parallel. So it has two sets of opposite parallel sides. The blue segments that you see drawn on the inside, those are the diagonals. So there's some properties that we can learn about parallelograms. First one, it says that the opposite angles of a parallelogram are congruent. So opposite angles are across from each other. If I were to remove the diagonals, they would be easier to see. So the opposite angles here are angle B and angle D, and angle A and angle C. Those opposite angles will always be congruent. They will always be the same in a parallelogram. Parallelogram consecutive angles says that angles that are consecutive, that are next to each other, those are going to be supplementary. So either D and C, those are next to each other, those are consecutive. B and C, A and B, A and D, any angles that are next to each other will always be supplementary, and we know that supplementary means adds up to 180 degrees. Opposite sides conjecture. We already know that opposite sides are parallel, but in a parallelogram, opposite sides are also congruent. So in a parallelogram, side AB would be the same as side DC, and side BC would be the same as side AD. And now those diagonals, the blue dashed lines that I have on the inside, they bisect each other. Bisect means cut in half. So if I wanted to mark this diagram further, I can also say that this segment ED is the same as EB, and I can say that EC is the same as AE. They're not all the same as each other, but E is the midpoint of both AC, and E is the midpoint of BD. A rhombus. A rhombus is a type of parallelogram. Everything that was true on the previous page for parallelograms is also true for rhombi, for rhombuses. It's just that a rhombus is a parallelogram. You take everything from the previous page, but then now add the extra property that all four sides are congruent. You see that marked with the four red dashes. Okay, a rhombus is just a parallelogram. Everything we know about parallelograms, but now all the sides, not just opposite sides, but all the sides are congruent. In addition to that, diagonals are perpendicular. You can see that also marked in the diagram. Here, we already know that the diagonals bisect each other, because that's true of all parallelograms. But now these diagonals are also going to be perpendicular, which makes four right triangles on the inside. And we know that the diagonals bisect the angles of a rhombus, so that's also marked for you. Here, this angle is getting cut in half, so you see the marks with one slash. Here, this diagonal is cutting this angle in half. This is getting cut in half, and this is getting cut in half. Now, since we already know that opposite angles are congruent, that's why you see 1, 2, 3, 4 angles all with one slash, because those are all congruent. They would all be the same as each other. Same thing here with the two slashes. All of these angles would be the same. Okay. A rectangle also falls in the parallelogram family. Everything that's true, not about a rhombus. A rectangle is not a type of rhombus, but a rectangle is a type of parallelogram. So everything that was true on the first slide about parallelograms is also true about rectangles. We accept all those properties as being true, but now with the added rule that all the angles are congruent. And when you have a quadrilateral, when all four angles are congruent, we know that all the angles are always going to be 90 degrees. Because in a quadrilateral, all the angles have to add up to 360, and 360 divided by 4 is 90. In addition to that, we have one more property with rectangles, and that's that the diagonals of a rectangle are congruent and they bisect each other. We already knew that they bisected each other because that's true about all parallelograms, but now we also know that they're congruent. So the distance from B to D would be the same as the distance from A to C. Don't get this confused with rhombus. In a rhombus, the diagonals are perpendicular. They make a 90-degree angle. That is not true about rectangles. Then finally, for the parallelograms, a square is a parallelogram. A square is a rhombus. A square is a rectangle. Everything that you've seen so far on the notes is true about squares. So a square, you can say that it's a rectangle with 4 congruent sides, or you can say that it's a rhombus with 4 congruent angles. It's the same thing. It's every property that you've seen so far is true about a square. All 4 sides are congruent. All 4 angles are congruent. The diagonals bisect each other. The diagonals are perpendicular. The diagonals are congruent. The diagonals bisect the angles. Everything that you've read so far is true about a square. Okay, and that's what this says here. As far as the diagonals go. Diagonals are congruent, perpendicular, and bisect each other. Another type of quadrilateral is a kite. Now, a kite has nothing to do with a parallelogram. A kite is not a type of parallelogram, but a kite does have, you'll see later on that a kite does have some similar properties with a rhombus. Like you can already tell that the diagonals here are perpendicular, and you'll see later on also with area. When we get to area, kites do have some similarities with a rhombus, but a kite is not a rhombus, and a kite is not a parallelogram. So with a kite, well, what makes a kite is that it has consecutive congruent sides. So we have 2 sides that are next to each other that are the same, and another 2 sides that are next to each other that are the same. The angles that are created where the 2 non-congruent sides meet, those are called the non-vertex angles. The angles that are created where the 2 congruent sides meet, those are called the vertex angles. So let's learn some things about kites. The non-vertex angles are congruent. So not the vertex angles, but the non-vertex. This angle here without the diagonal is going to be the same as this angle here. The diagonals, those are perpendicular. Okay, yeah, we mentioned that. That's going to be kind of the same as a rhombus, where because those diagonals are perpendicular, when the diagonals are drawn, that creates 4 right triangles. The diagonal connecting the vertex angles is the perpendicular bisector of the other one. Well, we already know that the diagonals are perpendicular, but what this tells you is that this diagonal that's connecting the vertex angles. Let me read that right. Yeah, the vertex angles is cutting the other diagonal in half. So this distance here would be the same as that distance there. I've already used the 1 slash and the 2 slashes on the sides, so that's why I marked this with 3 slashes, but those distances would be the same. And then the vertex angles of a kite are bisected by the diagonals. So if I look at the diagonal that goes from vertex angle to vertex angle, that's cutting these angles in half. So this angle would be the same as this one, and this one would be the same as this one. They're not all the same as each other. They're not all 4 going to be the same. But that one, the other diagonal doesn't cut the angles in half, but the angle that's connecting the vertex angles, that one does cut those angles in half. And then the last type of quadrilateral that we study is a trapezoid. A trapezoid actually has a lot of similarities with triangles, which is a triangle is not even a quadrilateral. But the 4 sides of a trapezoid have a name. The definition of a trapezoid is a quadrilateral that has exactly 1 pair of parallel sides. And those pairs of parallel sides have names. Those names are bases. Now the other two sides also have names. Those names are legs. So let's learn some information about trapezoids. Consecutive angles, okay, which are angles that are next to each other. Consecutive angles are going to be supplementary, okay? But it's the angles that are between the bases. So here it's only the angle from one base with the angle that's next to it from the other base. The angle from one base with the angle that's next to it from the other base. If you wanted a geometric definition, it's because those are actually considered same side angles. They're both on the same side interior angles. They're on the inside of the trapezoid, and they're on the same the legs act as a transversal to the parallel sides. So if you wanted to use the geometric definition as to why they're supplementary, it's because they're same side interior. Isosceles trapezoid. If your trapezoid is isosceles, the other time you've heard that word isosceles was with the triangles, and even though a triangle is not a quadrilateral, trapezoids do have some commonalities with triangles. A trapezoid can be isosceles. If a triangle is isosceles, the legs would be the same. If the legs are congruent, then you have an isosceles trapezoid. And the last property tells you that if you have an isosceles trapezoid, the diagonals are going to be congruent. So if this is true, that means that your diagonals would be congruent. They would be the same. Okay, so I'm sorry, we have one more here about trapezoids, and that's with a mid-segment. You also look, coincidentally, you also saw mid-segments with triangles. You can draw a mid-segment on a triangle. You can also draw a mid-segment on a trapezoid. Now, on a trapezoid specifically, a mid-segment connects the midpoint of the two legs. If I connect midpoint of one leg with midpoint of another leg, okay, then that is a mid-segment. And what we learn about that is that that's going to be parallel to the bases as well. It has to be parallel to the bases, and it's going to be the average of the lengths of the bases. So the way that you would find the length of a mid-segment is it would be base 1 plus base 2 divided by 2. If you add the bases and divide by 2, that would give you the length of the mid-segment.